Hello everybody, I came with the fourth subtopic, which is related to shapes and movements of the earth. Before I proceed into today's topic, let us revise the previous topic, which was about members of solar system. The third member of solar system is asteroids. So apart from the stars and the planet, there are numerous tiny bodies which also moves around the sun. So asteroids are relatively smaller rocky bodies. That orbits the sun. So most asteroids in our solar systems are found in the main asteroid belt. The main asteroid belt is found between the orbits of Mars and the orbits of Jupiter. The fourth member of solar system is meteorites. So meteorites are the broken piece of asteroids. The other one is when the meteorites enter to the Earth's atmosphere, we call them meteors. When the meteorites enter to the Earth's atmosphere, we call them meteors. So meteors are a streak of light in the sky. The other one is meteorites. Meteorites are formed when the meteorites survive and land on the surface of the Earth. Meteorites are formed when the meteorites survive and land on the Earth's surface. The other one is constellations. Constellations is a various patterns of stars. These various patterns of stars is formed by different groups of stars. So today there are around a total of 88 constellations. That covers the entire night skies. Some of the constellations are Andromeda, which represents Prince of Ethiopia. The second one is Cassiopeia, which represents Queen of Ethiopia, and Cephas, which represents King of Ethiopia. So this is all about the previous topic. Today we are going to proceed from shapes and movements of the earth. So first we are going to look the shapes of the earth. So Earth is one of the 8 planets in our solar system. As we know, Earth is one of the 8 planets which is found in our solar system. The Earth shape is not perfectly round. The shape of the Earth is not perfect round. It has slightly a greater radius at the equator. The Earth has a greater radius at the equator, which means around the equator it is wide. The other one is Earth is an oblate spheroid. The shape of the Earth is an oblate spheroid. Earth does not have a perfect spherical shape. It is, as we know, it is an oblate spheroid. Why this happens? When we ask this question, the oblate spheroid shape of the Earth is due to gravitational forces, which is caused by the rotation of the Earth. So the Earth is bulging in the middle. And the Earth is flattened at the North and South Pole. The Earth is bulging in the middle and flattened in the North and South Pole. The second subtopic is related to movements of the Earth. Before we are going to look the movement of the Earth, let us see the evidences of the Earth's shape. There are various evidences which proves the shape of the Earth. There are various physical evidences that proves the shape of the Earth is not perfectly round. The first evidence is if the shape of the Earth were a flat disk, then the rising sun would have been seen. At all places at the same time. But this does not never happen. We are not look the rising sun at all places at all the same time. We are not look the rising sun at all places at the same time. So places in the east see the rising sun earlier than the west, north and southern places. The other evidences which proves the shape of the earth is not perfectly round, rather it is an oblate sphere, is if the earth had been flat, the whole shape would have been seen at the same time. If the earth had been flat, the whole shape would have been seen at the same time. So the evidences prove that. Evidences prove that the shape of the earth is not flat, but it is an oblate spheroid. The other one is movements of the earth. Movements of the earth. There is nothing stationary in the universe. There is nothing stationary in the universe, which means the whole thing is which is found in the universe applies revolution and rotation activities. So the planets, the moons, and other heavy bodies, the planet, the moon, and other heavy bodies which is found in the universe rotates and revolves at different speeds. So Earth has two different movements. These movements are called rotation and revolution. First, let us look rotation. Rotation is the movements of the Earth on its axis. Rotation is the movements of the Earth on its axis. So the Earth takes about 24 hours. The Earth takes about 24 hours to complete one rotation around its axis. The Earth takes about 24 hours to complete one rotation around its axis. Earth rotates from west to east. Earth rotates from west to east, and the sun rises in the east and it sets in the west. The sun rises in the east and it sets in the west. So the Earth's axis of rotation is tilted. The Earth's axis of rotation is tilted at an angle of 23.5 degree. The Earth's axis of rotation is tilted at an angle of 23.5 degree, and it is perpendicular to the Earth's orbit. The Earth's axis is perpendicular to the Earth's orbit. So the tilt of the Earth's axis influences the amount of daylight. The tilt of the Earth's axis influences the amount of daylight or temperature and other weather patterns. So let us proceed from the effects of rotations, the effects of Earth's rotation. The effects of the Earth's rotation. We are going to look two effects of the Earth's rotation. The first one is variation in day and night. The variation in day and night, and the second one is high and low tides. So the first one is day and night. The rotation of the earth creates diurnal cycle of light, diurnal cycle of darkness, diurnal cycle of temperature, and diurnal humidity changes. The rotation of the earth creates diurnal cycle of light, diurnal cycle of darkness, diurnal cycle of temperature, and diurnal cycle of humidity changes. As the earth rotates on its axis, half of the earth's faces the sun, and half of the earth's far away from the sun. As the earth rotates on its axis, half of the earth faces the sun and half of the earth is far away from the sun. This is one of the effects of the earth's rotation. The second effect of rotation is high and low tides. So high and low tides are the result of gravitational pull. High and low tides are the result of gravitational pull. This gravitational pull is occurred between the sun and the moon. The gravitational pull of the sun and the moon results high and low tides. So one of the forces is usually stronger than the others. So this stronger force results for the formation of high and low tides. This is all about the fourth subtopic. Thank you for your attention. I'm proceed from the other subtopic for the next session. Have a nice time.